We're on this trend right now of finding derivatives of non-algebraic functions. We've done the derivative of the exponential function, and we need some more tricks before we start trying to do the logarithmic function, right? What can we do right now, though? We can do two other transcendental functions. Transcendental just meaning non-algebraic. We can do two other transcendental functions. We talked about sine and cosine. We want to ask, well, what is the derivative of sine of x? And what is the derivative of cosine of x? Now, we're not going to talk about tangent or cotangent or any of the other four right now. I guess other two, the way I phrased that. We're only going to focus on these two. And in fact, in this video, I'm only going to do sine. I'm going to leave cosine to you. Well, the derivation of it. I'll tell you the answer. All right. So how do we do these? Well, we're going to need some trig identities to perform these calculations. What are those? So here, I'm going to write it in exactly the form that we're going to need it. We have sine of x plus h. Okay? This thing here, it turns out that this is equal to sine of x, sine of h, plus cosine of x, sine of x cosine of h, plus cosine of x sine of h. Sorry, I was getting that a little backwards. Right? So this is the formula for sine of x plus h. And the one you'll need for the cosine derivative, we have cosine of x plus h. This is equal to cosine of x, cosine of h, minus sine of x, sine of h. Okay? So you'll need this one to do the derivative of cosine. We're going to use this one right now. So let's get on with this. So if f of x is sine of x, then f prime of x, right, we're going to use our same limit definition. Because we don't know anything about these yet, right? They're certainly not polynomials or any kind of algebraic thing. We have to resort to definition. All right, so we're going to use our usual f of x plus h minus f of x over h. This is limit as h goes to 0 of sine of x plus h minus sine of x over h. Now we're going to break up sine of x plus h according to this formula up here. Limit h goes to 0, sine of x cosine of h plus cosine of x sine of h minus sine of x, all this over 8. Okay, so we got that. Now what we're going to do is we're going to group these things together. These two both have a sine in it, so we're going to group them together. And then the other one will be sort of on its own here. So, limit as h goes to 0, we can factor the sine x out of those and get cosine of h minus 1. And then plus cosine of x sine of h. Again, all this is still over h. What I'm going to do now is split up this fraction into two pieces and then factor out the sine and the cosine x. And again, that's because the limit is only having to do with h. So I'm going to completely split this up as much as I can. And we wind up with this. H goes to 0, cosine of h minus 1 over h plus cosine of x, limit as h goes to 0, of sine of h over h. Right? So, being able to compute this derivative comes down to knowing the value of these limits. So, to actually figure out what the values of these limits are, of course you can do a numeric approach. To actually sort of verify this, it's a little bit trickier than what we're going to look at here. So I'm just going to tell you that this limit here equals 0, and this limit equals 1. Which means that at the end of the day, all we have is cosine x. Okay? So, to summarize that, the derivative of sine of x equals cosine of x, and the derivative of cosine of x, as it turns out, is going to be negative sine of x. Right? So here's a bit more variety in derivatives for us. That made sense.